Hey guys, this is Mr. Grice for Algebra Unit 10.1 Notes. Today we're starting a new unit on statistics. The first section today will be 10.1, which is all about linear correlation. Our learning target today is to identify the correlation coefficient of a set of data and to recognize if correlation signifies causation. So let's go ahead and get started. A scatter plot. Hopefully you've seen these types of graphs before. It is a graph that represents two variables by using scattered, disconnected points. Okay, that's very important. They are disconnected. Correlation is a relationship between two variables. You're going to hear that word, and linear correlation a lot. Linear correlation is a linear relationship between two variables. Okay, so if you need a little bit more time writing those down, please pause the video. Okay, let's go ahead and look at the types of linear correlation. So example A is a positive correlation. So the points in the scatter plot, so remember the scatter plot is the graph, the points form a linear pattern with a, see how it's going up? This is a positive slope. So if the general trend of the graph is going up, that means it's positive. Okay, now example B, which is negative correlation, that means the points in the scatter plot form a linear pattern with a, see how they're all going down? Yeah, that's a negative slope. And then we get to example C, and you're like, that's not really going down. It's not really going up. You really don't know what's going on, and that's because the points in the scatter plot do not form a pattern. Okay, so we can have a positive correlation, we can have a negative correlation, and we can have no correlation. So those are the types, and now the correlation coefficient is a number that represents the strength of the linear correlation. Okay, so when we're looking at this, we're looking to see whether it's positive or negative, or if it doesn't form a pattern. So positive, negative, or no correlation, but then we can really describe what it's like. Okay, and we give that a numerical value, and that's what the correlation coefficient is. Okay, now we can be all the way to the left right here at -1. That would be a perfect negative correlation. All the way here at +1, this would be a perfect positive correlation. And then there are these other areas in between where it could be strong, it could be moderate, and then it could also be weak. Okay, so and we have these ranges off to the side, and one of the things I wrote down on my paper is that whether it's perfect, either positive or negative, it could be 1. Okay, if it is a strong correlation, it could be plus or minus 0.9. That's saying it's very strong. Moderate, either positive or negative, is about 0.7. We would say weak is about 0.3, once again, plus or minus, depending on if it's positive or a negative slope. And then no correlation, we would just say that that is 0. Okay? So if you want to write this down to kind of help you remember, okay, there's two ways to look at it right there. All right. Once again, pause the video if you need to write that down. Okay. So what we're going to do is we're going to look at these graphs and estimate the correlation coefficient and describe the strength of the correlation, whether it's strong, moderate, or weak. All right, so looking at the first example, I can tell that it is positive, right? It's going up, okay? And see how close all of those dots are? Yeah, they're almost perfectly in a line, okay? So the first thing that we would say is that the coefficient, okay, we're going to say that it's 1 because it is perfect, okay, and it's perfectly positive. Now, number 2, they're almost all in a line, and it's going positive. They're very close, just not 100%. So we would say that the coefficient, now remember we're estimating, is about 0.9. Okay, it's almost perfect, but not quite. So if it's 0.9, we're going to say that that has a strong correlation. Okay, now number 3, I can tell the general trend. Okay, the general trend of this graph is that it's positive. Okay, it's going up. It's not perfect. It's not strong. We would say that this is moderate. Okay, so if we're describing moderate, we're going to say that that is about a 0.7. And that it is moderate. Okay, number 4. So once again with number 4, we can tell, I'm just going on the outsides now, that the general trend of this graph is going up, okay? It is nowhere near perfect or strong or even moderate. This is where we'd say this is weak, okay? So it's about a 0.3 and that this is weak, okay? So you can really get to see the visual difference between what a perfect, strong, moderate, and weak correlation all look like. Okay, now let's look at 5 through 8. Now, number 5, once again, you can see how they're all lined up in a line like that, but this time they're all going down. Okay, so our correlation coefficient, that is perfect, but it's negative this time. So we would say that it's -1 and that it is perfect. All right, number 6, once again, you can see the general trend is going down again. And it's strong. Okay, they're all very close together. It's just not perfect. So once again, we're estimating it's going down, which means it has a negative slope. And we would say that it is strong. Okay, 7, once again, you can see the general trend of the graph is going down. Okay. So we know that it's negative. It's not perfect. It's not strong. It's not weak. Yeah, it's moderate. So negative 0.7, and that it is moderate. And then the last one, number 8, once again, we can see the general trend of the graph is going down. Okay, so we would say that it's negative. Once again, it's not perfect, it's not strong, it's not moderate. Yeah, it's weak. So the correlation coefficient would be negative 0.3. And we would say that it is weak. Okay, that's the front side. Let's go ahead and flip it over. So now we're going to be talking about correlation versus causation. So let's read what it says. Johnny collected data for his science experiment. He wanted to see if there's a relationship between a person's shoe length and their height. A table of values containing the data he collected, as well as a scatter plot representing the data, is shown below. So I'm just going to reinforce where all of these points are. Okay, so this is all the data that Johnny collected. You can see his data in the table to the left right here. And so let's take a look at it. The first thing we kind of want to know is what's the general trend? Do you think it's positive? Do you think it's negative? Well, from left to right, I can see that the graph is, yeah, the graph's going up. Okay, now it's definitely not perfect. I wouldn't even think that it's strong. Yeah, I would say it's not weak, but yeah, it's about moderate. Okay, weak, the points would be farther together. Strong, the points would be closer together. So let's see what Johnny's saying. Johnny concluded that height causes a larger shoe length. Do you agree with Johnny? Defend your answer using at least one complete sentence. So what I would say here is, I don't believe that he's right. I'd say no. Okay. So now I have to defend it. So why do I say that? Well, there is a moderate correlation. Okay, between the values. Okay, I'll agree with that. There is a moderate correlation between the values, but just because you're tall, it doesn't mean that you're going to have big feet. Okay, even short people can have large feet. That's fine. So that's what we're saying here is, so just because there's some correlation, it doesn't always mean that the higher or the taller you are, you're going to have a large shoe size. Okay, so that's what I'm writing down right now. So there's a moderate correlation between the values. Okay, but tall people uh, don't automatically have big feet. Okay, and you can add, I know it only says one sentence, but this is my second, that even short people can have large feet. All right, so correlation and causation. So remember that correlation is a relationship between two variables. And causation is a relationship in which one variable and we can say that that is a thing or an event. Oh, sorry, one more. Or an action causes the other. Okay, so just know that correlation does not equal causation. Now, a strong correlation between two variables does not automatically mean that it's a cause and effect relationship. You really need to think about it. Okay, so here's some examples. There's a strong correlation between the amount of heat used in a household and the outside temperature. Is there a cause and effect relationship between the two? So what we're talking about is the heat inside your house and the outside temperature. What do you think? Is there a cause and effect relationship? Well, let's think about it. Think about the winter and it's really cold outside. What do you do inside? Do you turn the air conditioning on or do you turn the heat up? Yeah, okay. So for this one, is there a cause and effect relationship? Yes, okay. Because when it gets cold outside, it causes people to turn the heat up at home. And probably the same thing for when it's cold outside or when it's hot outside, people turn the air conditioning on at their house. Okay, so the weather causes, it affects us to change the temperature inside of the house. All right, in 2002, a study reported that there's a positive correlation between people with two cars and having a longer lifespan. Is there a cause and effect relationship between the two? All right, so the two things that we're talking about are people with two cars and having a longer lifespan. Is that a cause and effect relationship? So just because I have two cars means I'm going to live longer. What do you think? Yeah, I'd say no. Okay. Having two cars doesn't automatically cause that a person's going to live longer than someone who doesn't. Okay. So that's what I'm going to write down. Having two cars so having two cars doesn't automatically cause that person to live longer. Sorry, cause that person so live longer than someone who doesn't have two cars. All right, number 13. Why don't you guys pause the video and see if you can do that one on yours by yourself. It's saying that the shirt size of a grade school student, so shirt size of a grade school student and the student's vocabulary has a strong correlation. Is there a cause and effect relationship between the two? So if a kid has a large shirt size, that means they're going to have a larger vocabulary. And if they have a small shirt size, it means they're going to have a smaller vocabulary. What do you think? Go ahead and pause the video and try it out. Okay, so I said no. Okay, a student's shirt size doesn't cause his or her vocabulary to increase. A smaller sized kid can have a large vocabulary. Okay? So I know some of these can get tricky, but you really need to think about it. And if you're having trouble, please come see Miss Carranza or myself. We would love to help you out. All right? So your homework is 10.1 practice. And if you have any questions, come find us. Otherwise, this is Mr. Grice signing off for Algebra Unit 10.1 Notes. Thanks for watching.